Hello, and thanks a lot for being here. Thanks a lot for preferring to talk about infrastructure as code instead of ice cream. That's a pleasure for me to have you here. So today we're going to say how we are going to go from IaC, so from something that we don't like, to infrastructure as code, because I believe that this is something that gives a lot of improvements in our day-to-day life, and also improves our code diet. So let's see quick things about me in case you were not here in the other room yesterday in the presentation. So I'm Antonis. I'm a software engineer at a company called Platform Estates, where we do cloud hosting for web applications. I'm also part of the Docker Captains program, which is a public advocacy program from Docker, which is for people like me who do speeches around Docker. And we also run the Docker Athens, so if you happen to be in Athens and you want to go and see a Docker event, we'll be happy to have you there. In general, we also do a podcast, which is called Greek Veda. If you're not Greek, sorry, it's in Greek. If you're Greek, we'll be happy to have you as a listener. And in my day-to-day life, I mostly code in Python and Go. And some people say that whatever comes in my hands becomes a container, so I'm a very big container fan and lover. So let's see what we are going to do today in this talk. So first of all, we'll see the benefits of describing infrastructure as code, which are the things that we take out of it, and in which cases it's a better choice than the alternatives. I will see some use cases which are a bit out of the norm, but things I like to do in my day-to-day life and I really enjoy. We'll talk about tools, mostly a tool called Terraform, in case you've heard about it. We'll see some tips and tricks, and we'll have a slide where we'll discuss about the future, because who doesn't want to know the future? I don't know it, but maybe some of those predictions might come true. If you pay close attention, at the end we're going to have a quick quiz with some presents, or actually that was the plan, but unfortunately yesterday the presents were gone in the other presentation, so we're just going to have fun and learn something out of it. So sorry about that. We might still have some stickers left, so feel free to come by later on. So enough introduction. You're all here, hopefully, to learn about infrastructure as code. And the first question that comes to everyone's mind is, why should one describe their infrastructure as code? So that's a very valid question. And of course, as I always like to say, we don't want to introduce new technologies, new processes, unless they actually solve something. So hopefully this, throughout the presentation, will ask and answer some of those questions. And by the end of it, you'll know that it might make sense or not for your use case. I always like to use a story to picture what's the general context of infrastructure as code. And I'm going to go a bit back. So I think 5 or 6 years ago, me and Paris, we were doing our first Docker workshop. Throughout those workshops, what we do is that we offer some virtual machines to attendees, so that each attendee can have a virtual machine and run all the code from the workshops themselves, so that they can run all the exercises, experiment, and not break their own computer, but something that's reusable and in the cloud. So let's say that the story goes like this. The workshop is starting, everything's going fine. We have around 30 or 40 VMs running with different versions of Docker to experiment throughout the workshop. And at some point, one attendee raises their hand, and they have a complaint because the actual virtual machine is not working. They have a bug, or something was not bootstrapped correctly, or I don't remember the exact problem. So after that, we go to the attendee, we try to debug the problem, and since everything was written by hand, we need a lot of time to see what script was run in the wrong way, or what was the actual mistake that we did in the provisioning. This takes some time. The other attendees start to get frustrated because nobody wants to sit there and just do nothing and wait for someone else to get their code debugged. So after like an hour, most of the attendees are a bit bored. Some of them left the workshop, so the workshop was a total failure. And this is not something that someone would like to have in their own workshop. Of course, we're really happy because nothing of that is really true, and that we have provisioned everything using infrastructure as code. So what we actually had to do instead of all this boring stuff I was just mentioning just about now was to go back to the provider, pin a specific virtual machine as invalid. This kicked in the process that we had in place for the infrastructure as code. This machine was taken down. It was rebootstrapped from scratch using the same scripts. And 5 minutes later, the VM was up and running, and the participant could continue on their work. So this was one of the cases where you can see that if you have a very nice process, you have everything documented, and you have the specific tools in place, you can let the tool do the job for you, and you can focus on what you did the best. We wanted to deliver a nice workshop, and the attendees wanted to have this workshop they attended. They didn't want to debug any infrastructure issues. So now I hope that this was a nice example, and following on, we'll see how this can happen using infrastructure as code, and a specific tool we'll pick, which will be Terraform. So back to the initial question, why should one describe infrastructure as code? The reason is that you want to go back to sleep. You don't want to be waking up in the middle of the night and trying to understand what's wrong in the script that you ran before, or to the manual process that you run and you forgot one step. So by describing infrastructure as code, you can be sure that the same process will be followed each time. So whenever you need to rerun this process or correct a mistake, you will be sure that the actual result will be the same. This, of course, reduces stress levels, and I think we have already enough stress from COVID and all those things that we have facing the last few years. So we don't want infrastructure to be representing it even more stress to us. And of course, we don't want to screw up. And if we do things manually, I don't know about you, but whenever I try to do something, a step-by-step guide by hand, I always end up breaking things or doing things wrong because I'm really, really bored. So we don't want to screw up, and that's why we describe everything in code. And even if we screw up, like in the case that we described before, we can easily recover out of it because we have the process in place. We have all the steps described, not just in text, but in actual text that can be read by a machine in code. So what can one define in infrastructure as code? So what types of infrastructure? Is it just VMs? Is it what is it? So we can describe anything that has an API, actually. So whatever kind of resource, because resource is a term that we use when we want to describe something that we can operate on using infrastructure as code tools. These things can be virtual machines, so we can spin up a new machine or take it down, run a script on top of it to bootstrap it, so anything around it. We can define all the networking, so imagine things like security groups or which IPs are allowed to access which network, or imagine you having to go on different UIs of your provider to allow a new IP or to delete an IP that is not allowed. All these things can be described as code and be easily managed. We can manage things like databases. If we have this application from the provider, we can manage storage. And with higher level layers like platforms like Platform SH or similar tools, we can even describe our whole application stack as code. So infrastructure as code is not just virtual machines, it's not just networking, it's everything that can be handled as a resource and lives in the cloud. So it's a lot more generic and easy to use and handle. So what do we mean code? Because code can be a very broad thing. We can think that we can manage infrastructure as code by just running a bash script, for example, but this is not always true, and we'll see what it is. So code usually is something that can be read by a machine. So it's simple text. We all hopefully written some code up until now, so we can use some description and some commands in order to provision the actual infrastructure. This thing precisely describes the operations that need to be taken in place. So for example, I want a virtual machine that has this machine type, this amount of memory, this CPU, this whatever I need. So we precisely describe all the features of the actual resource that we're going to provision, and this resource will be bootstrapped immediately in the cloud. And also, it's like cooking. So when you follow a cooking recipe, you have specific steps and end results. So all the steps are being done automatically, as we'll see by the machine, and we only focus on the actual results. So this type of machine with these specs. So now let's go back to what is infrastructure as code. So infrastructure as code is having code, having this text that can be read by machines, so by software, describing the actual infrastructure. So instead of us going and doing things in the cloud, like let's boot a machine, we say that I want a machine. So we define the end result, and then we have very specific software that's going to go there, connect with the provider, with AWS, for example, in this case, and actually provision this machine for us. If I want an application in Platform SA, to just describe the CPU, the RAM, or whatever I need, and then my application is running. I don't do all those steps. So machine-readable format, that's the most important part, because it's really important to use this as the basis from where we work. Let the software do the work, no clicks. So I don't want to follow a process that I go step by step and add things or remove things or keep files externally from this code. And the actual cooking recipe that we were talking about before when we were talking about code is actually the end result, is the state of the infrastructure, and then we have the end architecture. So we have the world that we want our application to run in. So it's really more high level. So infrastructure as code, as we'll see, I have this quote. So someone told that I like to read a list of instructions and follow a manual process to provision infrastructure. Does anybody know which person told this quote? The actual is no one never, because people do not want to follow manual steps. We all want to do interesting, creative things, and not just follow processes and do all those things. So the UIs are there to help us when we want to debug things or to do something to experiment with. But when we want to actually describe our production-ready infrastructure, something that will run thousands or millions of requests each day so that we can serve our customers and our users, we want all this process to be well documented in a file and everything working as expected. So what are the benefits? First of all, as I told you, documentation. So that's a very nice side effect, because we are developers. We know that we never remember to write down documentation. So when we change a manual process, it's really common, and at most times we will not go back to the actual process to edit it if we do something differently. So if we change a simple command or the arguments or the parameters, we will not remember to go back to the documentation to change it. So by moving everything inside the code, by describing everything and the infrastructure in code, we have a very nice side effect of having the documentation there alongside the process. So the process is in code, and then the documentation is the one that provides the human readable context so that we know why we do things a certain way. Then we have all those nice helpers of us, which are called machines. And machines have a very nice specific feature. Machines can do things again and again and again and again and do the same process perfectly and not do anything differently or wrong if you have any issues. People, unfortunately, are not that good at that repeatable process. So we can offload all those repeatable tasks of adding a new IP, removing an IP, adding a new virtual machine to a specific network, adding a security group for security throughout all our applications. All those repeatable things can be easily handled by the machines. And until the machines are clever and strong enough to win us, we can use them so we can make our own lives easier. So that's a nice benefit until that time comes. And also, by having all the process there in code and not relying on actual user interaction with the UI, we can easily review and audit when things happen in our own infrastructure. Let's say that we accidentally open a port, and this port is being used to take some data out of our own infrastructure. This, by no means, is something that we want to have happening in our company, but in case it happens, we can go back in Git, in code, and see when this thing originated, and know for how long this port was open, and for how long an attacker could potentially go in and steal some data out of the infrastructure. So by having all this auditing process and at the same time have this review process, because we know what will actually happen when we describe what we want to change in the infrastructure, it's not just up to me because I might be tired, I might be having my mind somewhere else, but another person can go in and review all these changes. So by reviewing and having multiple people agree on the actual things that we want to change, we can be more sure that the actual change will not be that detrimental. Of course, it's not, there's no single solution to this tool. There are many different tools that we can use in order to describe our infrastructure as code. So there are tools like Terraform, OpenStack. Also, this is more like low level, but we have AWS CloudFormation, Azure Resource Manager template. So every provider have their own. We have Ansible. We have more high-level ones, as we told, for each platform that uses their own description file, and the list can go on and on and on. Of course, there is no one better than the other, but all those tools can be separated into different categories, and maybe depending on your needs and your preferences, you can choose one or the other. So what's the difference? What's the main differentiators that I believe that should be considered in order to end up with your preferred solution? So first of all, some of those tools are what we call declarative, and some others what we call imperative. We will talk more about it in a bit, but the idea is that declarative, we describe the end result, while on imperative, we describe the actual steps to go there. These tools have different resource management support. So for example, if I go with the AWS CloudFormation, I'm not able to manage GCP or Azure resources, and that's totally understandable. There are some of those tools that have active monitoring, while others are more like passive. So I execute something, while on the other case, I actively monitoring for changes. The active monitoring is not something that's there yet. It's one of the predictions that will go there moving on. And of course, at the end of the day, we always have some preferences on the language. So different tools use different languages. And by choosing a tool, we have to also like it in order to use it. So the most important thing for me when it comes down to the actual choice is declarative versus imperative, because we can have certain features or certain pros and certain cons depending on the technology that we choose in its time. So in order to understand this, I have a simple example that I like to say. So when we talk about declarative, we have things like, I want a cold coffee, black, without milk. So what I'm telling the barista is that I want a coffee to be as an end product, as an end result, in a specific way. So I don't describe how they're going to do it. While on the imperative way, we have to lay down all the different steps to the barista so that the same coffee comes out at the end. So I have to tell him or her to grind the beans, mix it with water, maybe add some ice, shake it a bit, and by no means add any milk or sugar in it because I like it black. So by laying down all the steps, I can make sure that the barista ends up with the same end coffee in the first place. The thing there is that the barista is very more proficient than I am in terms of making coffee, because otherwise I would be a barista and they would be a programmer. So in that case, instead of actually telling the barista what to do, because they know their work, they know how to do it, I just tell the end result. And then I believe that the barista will choose the best process, the best steps, in order to end up with the same result. The same thing is true when we're talking about tools that use imperative versus declarative way of describing that infrastructure. So in the first case, in declarative, I believe that the tool will choose the best path in order to go from the current state to the end state. So the tool will say, okay, I want one VM and I have 0 VMs now, so I'll boot a new VM. If I have one VM now, there's no need to create a new one. Or if I have a different VM, I'll need to shut it down and create a new one in its place. So all those things are very well described inside the code of the actual tool. So the tool will do that. And I will not be the one doing this on my own. I don't have to create a script from scratch each time I want to bootstrap a new VM, for example, which is what I would do in the imperative case. So first of all, what are the pros and cons for declarative infrastructure as code? First of all, it's easy to understand and review. We all know that if we have actual code, imperative code with different steps, is a bit larger as a document, is a bit harder to try to understand this. So it's always easier to review end results than actual steps. For me, it's easier to see VM equals 1 instead of, do this, and that in order to create an actual VM. Also, we have very specialized software that handles this creation or update in my infrastructure. So instead of relying on my own code, which is usually buggy, sorry about that, I rely on the code that many people write on the open source, and they are easily there to fix bugs and make sure that the best path is being taken on its time. Also, when we talk about infrastructure as code, it's easier to account for updates because I can go back, as I told, and see when a certain change was introduced in the code or when something happened. But on the other side, when we talk about the scripts, the imperative way, it's a bit harder to know when the actual script was run, how it was run, what was the logs or the end result. So it's a bit more clumsy. Of course, nothing comes to free. As we know in life, everything is either not free, makes you fatter, or you cannot do it. So in this case, we have also some cons when we decide to go with a declarative way. Sometimes all these tools do not have the best path to go to actually implement a partial update. So let's say that I update a specific value of my virtual machine, and it's quite possible that the tool will not be able to understand that this is a simple update, it just updates the value, and will try to completely recreate that resource for me. This is not always the case. It depends on the actual provider and many other different points, but it's really important to know that in some cases, infrastructure as code might not have the best path because the code that was implemented has specific cases accounted for. Also, sometimes if I do manual updates, I might know the best way to update something or to implement a script or to know when I need to run or not run something, while on the other case, I mostly rely on actual providers. So if something is not implemented in the provider, I might not be able to use it, at least not in an easy way. So of course, nothing comes for free. I need to know what are the problems I'm introducing in my system, but on the other hand, I need to know what I'm getting out of it. So it's really important to follow a good decision process when actually knowing what happens there. Now that we talked generally about infrastructure as code, let's go a bit deeper and try to talk more about a specific tool which is called Terraform. So Terraform is a tool that was created by a company called HashiCorp. They create a series of nice tools on DevOps if you want to check them out. And it's a tool that describes infrastructure declaratively. So as you might have understood up to now, my personal preference is declaratively describing infrastructure. And Terraform is one of the tools that do actually just that. It's using a language called HCL. So it's a language developed by them. It's really to understand and see. And it's also a very nice use case for this specific tool. So the first tool that actually used this language, if I'm not mistaken, was Terraform. So it's really nice and easy to describe infrastructure from virtual machines, Kubernetes clusters, Kubernetes infrastructure, networking, GitHub repos, you name it. So there are many different providers, so everything is pluggable. If a new infrastructure provider wants to go inside the Terraform ecosystem, they just can create a new Terraform provider. And by using that provider, we can then create our own infrastructure on top of it. All this library and community under the tool is really important. And I think it's one of the things that makes it really stand out from the others. Because if you choose tools like CloudFormation, which has like 100% of the feature set of the AWS, then you cannot easily manage other things out of it. So by using a tool that's infrastructure agnostic, it's easy to manage things like my DNS provider and my infrastructure provider and my Git provider and other things all together. So it's easier to see it on a higher level. Terraform has a very simple way of operating. So it gets three things as input. So it gets the previous state. So this is the state that I applied last time I ran the tool. It gets the current infrastructure status. So it queries the provider to see what's the status currently in that provider. And then it gets the code that I have added in my repository. Then it computes all those things, understands the current state of the infrastructure, and then using the code tries to see if I have any differences. So let's say that at some point in my code, I have a VM called VM1, and this VM1 resource has a value called CPU or RAM. If I change this value in code, then Terraform is going to pull this information from the provider, see that the virtual machine has 1 GB of RAM and 1 CPU, see that what I want to do, what I have declared, is different, and then I try to apply these changes. So depending on the actual change, Terraform might decide to either do a complete recreate. So let's say that I have completely updated the resource to a point that cannot be simply updated but needs to be recreated. Or if it's a simple change, it can just update it on the fly. So after it does all those decisions, it ends up with a plan. The plan are the actual steps, the imperative things that need to happen on the infrastructure so that I can end up in the result that I declared initially. So what I didn't tell you is that by actually declaring things, under the hood, the software is doing imperative things, all the steps that end up there. So this plan will be the recipe that will end up from the current state to the state that I want to be in my own infrastructure. Then we have another step. We can examine this plan, so we can review it, we can audit it, we can keep it for future reference, so we have this information. Someone else goes there and says, okay, you know, Antonis, you have a very nice plan, let's go for it and apply these changes to the infrastructure. And after the decision has been taken, we can merge the code, we can run the pipeline, or do whatever we have in our own process, and then the actual changes will be applied to the infrastructure. So the plan might be something like, go and update the tags of the VM to new version equals v0.2. So this is going to be one of the steps in the plan. And then the Terraform will go talk to the provider and say, go update the tags. Go delete and recreate the resource. So everything that will actually happen has been told to us before by the tool inside the plan. And that's really handy because we can go back and see, okay, you know, that's why a new bug was introduced. Or, okay, we thought that by updating this simple thing, we would just do an on-the-fly update. But we see that Terraform is going to recreate the whole resource, and this will be destructive for our own infrastructure. So we are not going to move forward with the plan. So Terraform, of course, is not, as every other tool out there, is not a tool that has everything solved. So we need to use specific tips and tricks so that we end up in a better life, because we don't want to mess with the tool, but we want to use the tool to actually solve our own problems. So first of all, one of the things that you might see when using Terraform is that if you start creating a very huge Terraform repository with different resources and different environments and brands, then this will end up with a very huge state file that will take a lot of time to declare updates or to understand what's happening or to do quick iterations. So my personal preference is that we split up this Terraform repository into different directories, each with its own sub, let's say, directory with the different needs for each case. Things that might be good differentiators so that we can split all those environments and those Terraform states. Could be things like environments. So my production environment and my staging environment do not necessarily need to be in the same place. If I have a multi-brand or multi-installation environment, then we might decide that we have brand A in this directory and brand B in the other one. Then, one of the most common things that we see that really speed up the development of infrastructure moving forward is creating modules. Modules in Terraform are reusable pieces of code. So let's say that I have a specific way of creating each virtual machine. So instead of declaring the same parameters each time I wanted to create a new virtual machine, I can create a module that wraps around it and has all those same defaults for my own company and preference inside there. Also, we can have modules for things that go together. For example, if I have a Kubernetes cluster, I might need something like a load balancer, a DNS record in my DNS provider, or other things. So I can easily create this and put it inside the module so that each time I want to create a new Kubernetes cluster, I just create this new module and all the other things are being created alongside it. Also, and last but definitely not least, because I've had lots of pain from this last bullet in the past, if you happen to use Kubernetes alongside Terraform for infrastructure, then you will see that the Kubernetes provider is not playing nicely when it depends on the actual cluster being created in the same Terraform file. So in those cases, don't mix up the Kubernetes installation with the actual infrastructure installation. Create your cluster, bootstrap it, do all the things in one place, and then in another place, go and apply things like your policies, your role-based access control, your deployments, or whatever you need to run inside Terraform. Personally, I like to describe all my infrastructure inside the Kubernetes cluster in Terraform, but I always do this in a separate repository, in a separate state file, and not in the initial one. As I was told a few minutes ago, the main problem for this one is that Terraform is not very nice to understand and do all the links in the initial bootstrapping of the tool, and that's why a provider like Kubernetes cannot depend on the cluster being created underneath it. Of course, if you're like me, you want to automate stuff and to describe everything in code because we don't want people interfering in any way. So there are other nice use cases, maybe not as common ones that you can use Terraform in this example, but in general, infrastructure as code in order to describe. So first of all, one of the things that I've seen that are really interesting is describing access control inside one of those tools. So this means that when a new member comes into the team, their email address is going to go into a list under their team, and then based on these values, the team and the member and the level, the seniority or whatever, this member will get access to many different repositories, to AWS accounts or whatever have you inside Terraform. So instead of having a very lengthy onboarding process, that a human being will go to GitHub to add repositories, to AWS to give access to accounts, to GCP to create this new email address, to whatever have you. You have everything orchestrated inside Terraform. So by just adding the new email address to a specific list, then all the other things are being created automatically. So that's very handy. And when that person leaves the company, you just delete that, and then they lose access from all those tools. So instead of not knowing or remembering what you need to add or delete in its case, you just add and delete emails in a specific list, and everything works for you because, as we told, machines are very good at doing repetitive stuff, not humans. Also, we have many cloud providers like Platform as where they have their own definition, and through a simple file, you can create whole applications like your database, describe your memory, storage, CPU, RAM. The same is for your application. So this is really handy because I can just put a file inside my Git repository, push that repository to a specific provider that supports it, and then my application will be up and running in a URL within minutes. So by describing everything in code, I can easily update something, push it again, and then the new version of my application will have the new infrastructure underneath it. Last, but definitely not least, managing GitHub repositories, because we know that we have many different GitHub repositories. We have specific defaults we want to apply. GitHub has some same defaults and allows us to configure some others, but not everything can be easily configured through GitHub or all our policies, things like nobody's allowed to push to main. Main should be only rebased and merged, not merged with a merge commit or whatever other specific process that we have in our company. Then we can all describe those inside a Terraform file. And whenever we want to create a new GitHub repository, we can go to Terraform, add this repository name to the list of repositories, and then this repository will be created with the same parameters. And why the same parameters? Because the GitHub repository will be a Terraform module, so it will have all the wrap around it that we have for our specific use case and company. So as you see, a very common theme here is that we can easily use and reuse all those things again and again. And of course, because guesswork is my favorite thing, and because if we don't do some predictions for the futures, we will not have the chance to be full in a few years. So I'm trying to describe what I see the infrastructure as code thing going forward. First of all, I think it's here to stay. So if you disregard it, please don't. I think that it solves many problems, and it might be here and more interesting in the future. But apart from that, I think that languages which are more dynamic, like Q, I don't know if you've used, anybody has used Q before or seen about it? Well, just a few people. Okay, so Q is a language that's very similar to JSON. So it's a very nice and easy to understand language, but at the same time, it has some dynamic properties that allow you to do things like add the default values, or if something is missing, do something else, or pull a whole repository of Q files inside my file. So I think that Q will be one of the languages that plays an important role moving forward. I think that systems that actively monitor your infrastructure and see if the actual state has drifted or things are not working as expected, then and then try to reapply the changes, things like HIPAA compliance, for example. Let's say that I accidentally give access to a person that is not allowed to access a bucket through AWS, through the console. I will not know this until I run the next plan in Terraform, but with tools that actively monitor those things and make sure that HIPAA compliance is there at all times, I can easily do it. And of course, I think we can easily monitor and integrate infrastructure as code to monitoring tools, so that, for example, if something goes wrong, then the tool itself will know how to remedy it. Let's say that we have a downtime because of load, then the tool will be able to scale the cluster or do such things. So I think that things like autoscalers and monitoring tools will start to get more closely integrated with the actual plan of the infrastructure as code, so that they can remedy all those issues and see where it goes. And of course, these are predictions and guesswork, so I hope it happens, but I have no clue if it will. Of course, now we have a few minutes for questions, and feel free to ask any, but at the same time, if you want to play the game, you can scan this QR code or go to kahoot.it, and then we'll see who's going to be the winner at the end. So any questions until everyone scans this QR code?
Raise your hands if you have a question.
Yes, I don't see any thing.
None?
No, everyone is busy scanning as I see. Okay. So this is very simple. You will use a platform called Kahoot, and then when you go there, your phone will be a remote, and then you will see the questions in the screen, and then you can answer on your phone. The most correct ones and the fastest ones will be the ones that will actually win the podium at the end. So let's give it a few more seconds, and then we can go for it. At the same time, if anyone has any questions or anything, feel free to raise your hand, and I'll be happy to take questions. Okay. Okay, so let's go. So the first question is coming up, and the question is, drum roll. Okay, it has some nice UI. So infrastructure as code allows you to choose one of the options. Describe your infrastructure in code, run code deployments in your infrastructure, debug your code, manage infrastructure description and documentation alongside each other. 3 more seconds. And the answers are red or green if you selected one of those. So Envas, Tolis, and Tassos are the three first ones. So declarative infrastructure describes the end result and not the steps. True or false?
It's a great game, I must say.
Sorry?
It's a great game.
Yeah, it's fun. I mean, so the answer is true, because we told that the imperative infrastructure is the one that describes steps. So Tolis got the lead, Tassos, and then Ioannis. Let's see, who's next? Who's the first one? Terraform is using, which language? HCL, YAML, JSON, and Python. Ten more seconds. Let's see. Put in your answers. And the answer is HCL. We told that this is the language by HashiCorp. And we have Or taking the third place. Let's see how it goes. Last question. You have to be fast. I should put everything in a single Terraform state at all times, true, false. Answers are coming in. And the correct answer is false, because we said that for different environments and different cases, we might need to use different states. And the podium in the third place, Or, congratulations. Second place, Tassos Dousis, congrats. And first place is Spotlight, Tolis. Congratulations.
Well done.
So thanks a lot, guys. If there are no more questions, I would like to thank you for being here and not in the ice cream booth outside. Feel free to follow me on Twitter or LinkedIn or whatever, and I'll be happy to chat.
Thank you so much, Adon.